Hey guys, my name is Stacy and welcome to part 3 of interpreting research. If you guys haven't watched my last two videos, I would request you to please watch them. That way you will understand what we are doing in this video. Okay, so what we're going to do in this video is we're going to use concepts from video 1 and video 2 and try to use it on real world scenarios, right? Which means that we'll take up a popular claim on internet and try to analyze that claim critically. I'm just going to do a basic brush up of what we have learned so far. So we've seen types of studies. We've seen case studies, we've seen mechanistic studies, in vitro, in vivo, case controlled, observational studies, right? So case series and all of those. And we also saw how those studies typically rank much lower in the EBM, the evidence-based medicine pyramid. And we saw how systematic reviews and meta-analysis and Cochrane and RCTs are typically the ones that we have to pay attention to. Everything else, while they have their place in the system, but they don't rank typically very high. And so when it comes to human considerations, for example, prescribing an advice to someone, they should not be based off of these case studies and mechanistic studies and whatnot, right? So we'll primarily limit ourselves to systematic reviews, meta-analysis, and RCTs and double-blinded RCTs, right? So this we learned in the first video. If you haven't seen it, you can see this on my YouTube. Second video, we saw different kinds of statistical tools. So we saw basic mean, median, we saw standard deviation, we saw what is a hypothesis, what is an alternate hypothesis, what is a null value hypothesis, right? And then we saw how all of the data can be validated. We also learned about central distribution. We saw the bell curve. We also saw heterogeneity, right? In case of systematic reviews and meta-analysis, right? So we saw some of these tools. We also saw a confidence interval. If you have not heard about these things, please go and watch my video number 2. So let's use all of these things now and understand how to critically debunk, or let's say validate, information which is out there on social media. So social media, we have some popular claims around shilajit. A lot of people have claimed that shilajit boosts testosterone. Now, obviously me, someone who understands a little bit of biochemistry, I understand that testosterone production is extremely tightly regulated via your HPT axis, right? So you have the hypothalamus, and then you have your pituitary, and then you have your testis, right? So I'm just gonna make this almond-like gland. This is the butterfly-like, and then of course you have pair of balls, right? So you have HPT axis, right? So here you have a gonadotropin release hormone, then you have pituitary gland which releases LH and FSH, and testis is really what releases testosterone. All of this is controlled very tightly in the body. Now the problem with shilajit and the claims is that they say, hey, I mean, you don't need to know the mechanisms behind why shilajit works as long as it works, right? So fair enough, we don't know how it works. Let's assume it has some magical properties and it works. So let's try and validate. If we really do have evidence, if we do have statistical evidence to prove that shilajit actually works, even if there are no understandable mechanisms of its action. Okay, so the first thing I'm going to do is I'm going to go to PubMed. Okay, so let's do that right away. I'm going to go on PubMed, and we know that PubMed is a repository, so you have almost 30 million plus studies which are indexed here. So what we're going to do is we are going to search for shilajit related studies. Okay, so one of the things that I've noticed is that shilajit has very few number of studies. You can literally see like 20 results. So it's not something which has been audited or studied extensively or thoroughly. Because to put things into perspective, let's just search how many creatine studies are there. Look at that, there's about 6,400 results when it comes to creatine. Let's check for whey. Wow, there's over 2,500. Anyways, doesn't matter. Let's assume that shilajit has some early evidence. Shilajit. And what we really want to do is we want to pertain or limit ourselves to systematic reviews. And so there's 20 results. What I'm going to do is I'm going to apply some filters, and there's a filter already there. So what I'm going to do is I'm not going to refer to books and documents. I'm not going to refer to general clinical trials. What I'm going to do is I'm going to refer to meta-analysis, RCTs, reviews, and systematic reviews. Let's eliminate review for the time being. Okay, so when we have systematic reviews and RCTs, we come to 7 studies, and out of these 7 studies, let's look at studies which only specify shilajit and testosterone. So you have got one study. The second study does not mention testosterone. Third one seems like a systematic review, so we'll look into it. Okay, so fun part, there's actually not many studies on shilajit and testosterone, and there's one review which is based on exactly what, because I mean systematic review is supposed to be based on multiple RCTs and double-blinded RCTs and more studies, but since there's one study, let's just open this study for the time being. Okay, so it's a RCT published in 2015 in Andrologia. I've also told you how to assess journals by their impact factor, so we know if it's a good journal or if it's like a paid for journal. Again, I'm not alleging, but I'm saying happens a lot. Andrologia impact factor. All right, so as of 2020, let's check 2025. Okay, so Andrologia latest impact factor is around 2.1, which is lower than 3. And I've told you that when the impact factor is less than 3, usually it's kind of shady, so, but it's okay. Let's assume that the study is still holds the merit on its own. So let's see if we can find some full links. Okay, here we go. All right, so this study, like I told you in the last video, the structure, it's divided into abstract, which we saw. Then we have the summary, we have introduction, we have materials and methods, we have selection criteria, inclusion, exclusion. We have, this is observation, so this part is not necessary, it's just a questionnaire that they've asked. Then we have statistical analysis, and then we have results, we have a discussion, conclusion, and acknowledgements. Right, so one of the first things that I notice here is that this study is actually funded by the company that makes shilajit. So they've given some background, and if you look here, it says that purified shilajit, Primer V, Kolkata, West Bengal, India, a patented standardized extract of native shilajit from Natrion Inc. So what we're going to do is we're going to see what exactly is Natrion and why is Natrion so interested in publishing studies around shilajit. Okay, so when we go to Natrion, it turns out that Natrion is actually a company that's selling Ayurvedic products to bring scientifically tested and proven Ayurvedic products to the dietary supplement personal care. So this company has a huge conflict of interest, right? So study has a red flag. It's being funded by a company that makes shilajit, holds patents on shilajit, and sells shilajit. So it is in their best interest to make sure that study has a favorable outcome, right? Now, assuming, even if we ignore the red flags up until now, poor impact factor, funding, let's see into methods and materials. Okay, so the study, they recruited 145 volunteers between the age of 45 to 55, no problems there. Out of these 145 volunteers, roughly 49 among them were excluded for various reasons. That's fine, normal, happens. Ended up with around 37 and 38 subjects. So group 1, they gave pure shilajit, which is 250 mg. So they gave it to 38 subjects, and group 2 was a placebo, and they gave around 250 milligram of your placebo solution, right, which is not shilajit. And they have not mentioned any other criteria, any other regimen. They have not accounted for confounding factors. They have not given any training details. So we don't really know if there are other biases which might also have come into it, because right now what they have done is they've just mentioned that these were healthy individuals between 45 to 55, which is, in today's time is kind of, but it's okay. All right, so let's go down. They did the measurements. They did a measurement on day 0. They assessed their baseline testosterone, luteinizing hormone, follicular stimulating hormone, and DHEA, which is your epiandrosterone, right? So they measured their free LH, FSS, and DHEA, and they measured it on 0, 30, 60, and 90th day. And they noticed that was a 19% change from the baseline levels to day 90. They mentioned 19% change. Now, somebody who does not understand the data would say, wow, that looks significantly, clinically significant. And so if we look at the table, we come to the table, they've divided the table into two parts. One is your PS, which is pure shilajit, 250 mg. Other one is placebo. At the beginning of this thing, you can see the first column, which is testosterone, and second column is free testosterone. So testosterone went from 4.84 ng per ml to 5.83, right? So it's a significant jump, right? In a similar manner, the free testosterone went from 15.36 to 18.3, which is also clinically significant, up to roughly 20%, 19% jump in both testosterone and free testosterone levels, right? So, and when you look at the placebo group, you see the baseline was 582 and it went down to 445. In a similar manner, the free test levels were 19.3 and it went down to actually 12.21. So it seems like that people who were consuming shilajit actually saw positive results in their testosterone and free testosterone levels, wherein the people who were given placebo solution, they actually had decline in their testosterone levels, right? So it seems like, wow, this data looks great. It's a double-blinded, placebo-controlled, randomized controlled trial, and then they did a t-test, which is also fair. Now let's find out the problem with the study. You see these parentheses below testosterone levels. So this is your standard deviation. Okay, this is your standard deviation. Now look at we just focus on testosterone and free testosterone levels, and rest of these parameters, again, no need to get into details. Let's just focus on testosterone and free testosterone. So at baseline, the testosterone levels were 484 plus minus 1.54, right? So which is your standard deviation. Now the problem, and I'm going to write these results here, baseline. Okay, this is day 0 and this is day 90. Okay, so testosterone levels are 4.84 and 4.84, 1.54, 4.84 plus minus 1.54, and day 90 they went to 5.83, 1.67. Now what we have to understand is that there's a problem with the data. The problem with the data is that this is roughly 30% SD. Okay, this is roughly 30% SD, and in case of free testosterone, the SD is almost 45-46%. Now anybody who understands a little bit of statistics would tell you that this SD is extremely high. Okay, when you have a 30% standard deviation in your before and after results, that means that your values are not centered around the mean. Remember in the last video we talked about how most of the values should center around mean, because if the values are not centered around mean, what can happen is that they can skew the results. Okay, they can skew the results. If the values are too widely dispersed and not around mean, then it can skew the results. To give you an example of this, let's assume that there's a classroom which has results like 10, 10, 10, 10, 10. Okay, everybody got a 10, 10, 10, 10. Now this has a very unique distribution. Everybody was got similar marks. So and if you take out the mean for this, it will come out to be 10. Right, and because the mean comes to be 10, most of the values are around 10, right, which means that the results are good. The distribution is a perfect bell curve, right? But I can skew this result by saying, let's say this is 20, okay, this is 0, this is 0, this is 0, and this is, let's say 20, or maybe let's make this 10. Okay, so now you see that two people actually got 0. Now I can make it even worse. Doing what? I can make it minus 10, okay, and I can make it 30. I can make this also minus 10, and let me make this also 30. And so in both the cases, the mean is going to be 10. But in the first case, the results are uniformly distributed and we'll get a perfect bell curve. In the second case, you're not getting a bell curve. What this is basically manipulation of data. Okay, so this 30% standard deviation, 46% standard deviation in the final results It means that the values are not centrally distributed. There's a good chance that 1 or 2 individuals out of those 38 individuals, they had disproportionate results, maybe because of doing something else. And then some people did not have any effect, and some people also had some sort of negative effect. Because they have not mentioned specific user details, nor have they mentioned baseline data, we can't come to a conclusion. But as far as this is concerned, it looks like the data was fudged completely to make it look like a good study. On top of that, they also did not mention any kind of confidence interval. They also did not mention any effect size or Cohen's d. Right? So all in all, this study is shady. It's filled with biases. You can see that the data has been manipulated, and you can see that this was published in a journal with a low impact factor. On top of this, it's funded by the company that sells shilajit. Okay, so there you go. And because this is the only RCT, I don't know how much it makes sense to go through any of the other systematic reviews, because the systematic review is supposed to refer to multiple RCTs. And this systematic review, I mean, we can go through it. But again, look at this. This also mentions that a pure blend of blah, blah, blah. And then it keeps mentioning how Tesnor and purified shilajit extract primary can be considered possibly effective for men with, again, it refers to single study which is funded by Netrion, right? So all in all, when it comes to shilajit, there's literally very few researchers. One study which I've just told you the problems with data and funding biases, and there's nothing else pretty much, right? So this is how you go about looking at evidence and then make your assumptions or make your reels. Do not blindly just follow something because some influencer is selling something online. You have tools. You need to have a little bit of know-how, understand a little bit of statistics, understand a little bit of critical thinking, and you can do this too. If you haven't watched my last videos, please do so. It will help you massively. I hope this is clear. Thank you.